Welcome to systems engineering. We're going to start out by just trying to define what is systems engineering. What are systems? From there, we'll move into a framework and go into more detail with the planning, conceptual design, verification, validation, and close with a project. So enjoy. Let's get started. The word system brings out all kinds of conceptual ideas, relationships, abstractions. There's solar systems and communication systems, banking systems, social information systems, pulley systems, river systems. On and on it goes. There's just the word system covers so many domains. But for our purposes, defining systems engineering, a system can be defined as a set of elements that interact to achieve a stated purpose. So let's think about that a bit. A set of elements that interact to achieve a stated purpose. That's how we're going to define a system in systems engineering. So if we're trying to take a look at this a little bit, just sort of a graphical conceptualization, you've got these system elements, and they're all interconnected. They interconnect with each other. This is the system of interest. And at least in terms of a delivery of a product and or conceptualizing this a little deeper, we have the system boundary. So within this system boundary are all of the system elements, and they're all interconnected to form what's called a system of interest. We now need to take a look at what really is the mission of the system. We've got to define this, and you're going to see this throughout the study of systems engineering, is that, we got to define things. We got to be tight on our specifications. We got to know what really are the needs and requirements. And you're going to see that as we go deeper. But the mission has got to be clearly stated by the owners, by the business management, the stakeholders, because it gets us started in the whole design process, which is a major component of systems engineering. So it's also going, by knowing the mission, it's also going to give us some sort of basis by which we can evaluate, test, assess. Did the system meet what it was originally defined to do? So in the broadest sense, as they say right here, the mission of the system is to provide a solution to a business problem. And think of business loosely here. It's the entity that needs the system, that's going to acquire it, that's going to pay for developing it. Really, when you start thinking about systems, there's a variety of kinds of them, but there's really four main classifications that we're going to talk about. There's the closed open system. Excuse me, let me move that back. There is the closed open system. And there's the natural to human-made to human-modified system. There's also physical conceptual system, and it's either precedented or it's unprecedented. Those are the major classifications of systems. For our purposes, we're really going to focus on system engineering as applied to open physical systems that are human-made or modified from a largely precedented elements. We're not into the research game here. This is, we're going to be specifically looking at physical systems that are human-made or modified, open, and we'll talk about that a little bit more, and they're largely precedented elements. All the elements that make it up have already been developed. So again, looking at this system from a conceptual diagram, what is its environment? And again, we have this system boundary, and inside of the system boundary are all these elements, and they're all interconnected. There's interaction between these elements. This is the system of interest. You'll notice out here there's an external element, and it connects. How do things connect with internal elements within the system boundary? There's some sort of an interface, an external interface, an input, an output. It can be switches in software. It can be what's called a programming interface. You want to interface with my program. Here's how you have to do it. Frequently, what you're going to find is that, at least in terms of a physical perspective, a physical sense, the term system sometimes too frequently is considered to really be a product. The project is delivering a system, or is delivering the project is delivering a system, or is delivering a product. So just keep that in mind. Typically, that's what we're talking about, some sort of product. So the system can really be thought of, there's operational products, so there's an end product here. But there's also these things called enabling products. There's a development product, a test product, a training product, and a disposal product. As you evolve through this process. So when you look as a system, as a product, you can have operational products and enabling products, the products that get you to this operation. But don't be fooled into thinking that systems are just a bunch of hardware, software all put together. There's critical components related to the organization, the personnel, the collective, the training systems. You'll notice this word organization in here. This course is founded based on the Coursera course from University of New Queensland. University of Queensland in New South Wales. And that's how the organization's spelled in Australia. But systems really include personnel, organization, there's collective training, support, operating, how you're going to dispose it, how you're going to train, what are the policies. Everything is included in the system as a capability, because a system really is going to deliver you an operational capability that you didn't have before. It's not just about the products is the point. It's what is the operational capabilities it's now delivering you. So each of these elements of a capability system, they may have a different acquisition cycle. When you bring them on, how you bring them on. It could be a different type of acquisition mechanism. One is contractual, one is you're just procuring. But in this course, we're going to focus on the major equipment element. Otherwise, you can just, tens of thousands of pieces of something may go into a system. But you have to acquire all these elements in some sort of parallel so that they're brought back into service at the right time, under the right conditions, for the right price, in order that you can actually deliver an operational capability. So it's quite a process to make sure everything's coming in at the right time. A lot of logistics, a lot of pre-planning, a lot of checkpoints. It isn't just check, are they hooking up, but is it delivering what you originally set out as required and needed? Finally, I think it's important to understand that there's logical and there's physical types of system. Logical is what the system will do. You know, can we do it? How well can we do it? You're thinking it through logically, and as you put all the pieces together, all the different pieces, are there other systems that will be involved with this system that I need to have a connector, an interface of some kind? Physical is what the system elements are, how they actually look, and how they're to be manufactured, integrated, tested. So there's two, in a broadest sense, you've got to look at it logically laying out before you even build the physical part. So both the logical and the physical are what are defined as system requirements. What are the specifications? Interestingly enough, this is very similar to the procurement process at school districts. In the next video, we're going to talk a little bit about the hierarchy, the hierarchy of hierarchical way of looking at these logical and physical systems. We're going to look at this concept of systems of systems. It can get pretty carried away, but that's in fact on a large project, that's kind of what you've got. You've got a bunch of systems that are embedded within a big system. And then we're going to define a little bit of this problem and the solution domain. Who looks at what? Who lives in what? Who needs to be focused on what?